I write a compiler for a small Oberon-like programming language that targets RISC-V, 32 bits. The compiler is already written in itself, but not finished yet. That means that I can only use the features that are already implemented, and there is still a lot of things that are missing. And today I will begin with the intermediate representation, or with assembly generation to be precise. I want to reduce the number of the temporary registers that are used during the assembly generation. And temporary registers in RISC-V are T0, T1, and so on. And I use T4 and probably T5, and this shouldn't be really needed. So I want to use only T0 and T1 probably, and this way we can free up some registers that can be used later during the register allocation. So I think actually T5 is probably, no, T6 is the last temporary register, and it isn't used. T5 isn't used. T4 is used here during the move instruction generation. And in this case, if both registers to the move instruction are pseudo registers, then we need this T4 value to save an intermediate result. So let us just replace it with T0. I also want to write down the name of the function that we call with the T0 register. Probably we do not need the argument, this register argument, if we always use the same register, but I'm not sure yet. We will need to check this. And the first thing that I do is to compile this compiler with the previous stage of the same compiler, and then to do the final check with rake. And the final check passes. That means that we are fine, and there are no further T4 usages. So let us look for T3. And for example, for a binary instruction, okay, we will need this register argument for the ELNA alloc operand, because to allocate a binary instruction we need at least 2 registers. And this is actually the only case where it is used. So I suppose we can just replace them with T0 and T1. Okay, that looks fine. Then we have T2, also only 1 usage. And probably we can just replace it with T0. looks fine as well. And let's look for T1. So this is the store instruction, and T0 is already used here. So probably using T1. So if we have a store instruction, we allocate the first operand and save the result in T0. But why isn't used after that? So here we see that if we remove this this procedure call, then a store word instruction is generated with a pseudo register. This pseudo registers begin with a $sign. Oh, I see. I use instruction operands kind, value, and length. And this is probably the register. Let us try it out and just replace this thing with the ELNA RTL register. And this is actually wrong. T0 ELNA RTL kind register and then 0. Yes, that looks fine. And I hope here we just pass these values to this allocate variable. So the second argument is variable and the first argument is actually this T0. And then we save it in an offset for T1, but where is T1 allocated? Okay, this is the allot instruction, and then we have the store instruction. Okay, that's fine. So that's fine. Where is T1 used else? For example, here. This is actually very similar, I think. And a tele register, so here is only the stack pointer and T1 is used to replace it with T0. And then T1 is used only in this allocate binary function and during the generation of the store instruction. And that's actually it for this thing. As next thing, I want to look into the types that I into the built-in types that I add into the symbol table, and I want to add a few more types, even if not them can be used yet. So this is the built-in types. They have the kind primitive, and we have the word, the pointer, and bool. And I want to add more built-in types. The one of them is almost the same as bool, and it is a character. Its alignment is 1 and size is 1. It is a primitive type. And type info create shouldn't be called like this. What is actually for? Oh, it is the length of the word char. Exactly. Let us rename this type info function. In the early stages of the compiler, all functions had to begin with an underscore, but it is not the case anymore, so we can rename them without the underscore. And let us check whether it works. And I saw a few more underscored functions in here. So this is name type expression. It isn't interesting, but this temporary info create can be also renamed. And this procedure info create as well. And we have a compile function. Oh, let us do a quick test. Looks fine. Compile. Initialize global state. This one is used once, I hope. And now we are at this main function, and the thing with our programming language is that it is a Pascal-like. That means that it does not have a main function instead. So I have a keyword at the beginning of the file. This is a program keyword. There is no need to define a program name, but just to say that it is a program. And if it is a program and not a module, then it will, after all the procedures, it can at the end it can have a begin keyword and then end keyword and then a dot, and the body of this function between begin and end is actually the main function, and the main function is generated automatically, or probably it will be later the start function for Linux, winmain for Windows. So this code, this procedure main, should be replaced with begin end block at the end of the file. We cannot do it in this stage because it won't work. Instead, we need to define a new, it wouldn't work because the previous stage of the compiler cannot understand it. So we need to define a new stage. It will be the 21, I think. So I'll exit here and we look at our stages, and the last stage is 20, and we are going just to define, just to copy the current stage 20 into the stage 21. And another thing, I have a rake file, and the rake file helps me to work with stages. So during I work on a new feature, I just implement some code that copies the current stage into the next stage and adjusts a few things, basically this main function, for example. So here we open the stage 20 and now the stage 21, and we copy the stage 20 into it. This added some code previously that I used for testing. We do not need it anymore, so we just put a comment here, and I hope this should be it. Probably we need to recompile all the stages. No, it actually picks up. No, it doesn't. We need to recompile. We need to rebuild the Ninja file. So what we are going to do, we remove the current build Ninja file that we use for compiling the compiler, and now I can regenerate this one. And now if I do now it compiles the new stage. And the rake command should pass as well. I think I do not hardcode the stage in the default task, so default task is boot, and task boot is this one, and it just uses the latest stage, so it should be already fine. a bit unfortunate is that I use local variables here. We probably had to rewrite this first into a helper function. So I have here this compile function. Actually, I don't know, we can just move this logic where this variable used last read is used in the file reading, offset as well, read the source from the standard input. What is the source code? Source code is a global variable, and it is just a word. And we increment the offset, so offset is a pointer into the source file current position where we write current read position. So I do not have loops yet, therefore I use goTos with if statements for the loops. So let us split the screen and we go here to the compile function, and we do not return from it, but we just say that if compiled, it seems to be a boolean, then we exit with a 0. Otherwise, actually compile just does the compilation. It is not correct to combine it with everything else, where we handle probably file reading and stuff like argument handling. These functions can also be called from the main functions, so it is not a problem. Actually, only the file reading is kind of problematic. Lexa state. Why do I initialize the Lexa state here? What would happen if I move the Lexa state in here, initialize it here, and then I do not need this cursor parameter in the compile function? I then need to replace the cursor with the Lexer state pointer, and this actually should be fine. Yeah. And this one just reads the files, the source, and it writes the source into the source code, but it should allocate the storage somewhere else. And the storage is allocated, so we allocate just some amount of memory, not as much as we need, but more. And we can just define a new procedure and call it read source. And we move these variables into this procedure, and we move this file read into this procedure. And then we can call it before we begin with the compilation of read source. Okay, that looks fine. And now we can rewrite this main function. This should be done probably during the parsing stage, and I probably need to extend the data type, the abstract syntax tree data type that I use for the program representation. Okay, procedure declaration. Here we have a loop. Procedures. And this parses a list of procedure declarations. And procedures. And it is called here, and it is written into the result, and the result is actually the ELNA3 module declaration. Let us add the return type and probably move to the top half, because I can see that better. So we have this module declaration, and it returns now a pointer to the data structure. I think that the main function is just is just a list of statements, I suppose. So, and we will add also a few return types. I think it probably would be good. So if we look at procedure declarations function, it has this result variable, and it is probably the thing that is returned. So we can just add it here. And the same actually for procedure declaration. So it has result LNTSC procedure. No, it is LN3 declaration, so it is a more generic type. And here we have LN3. Oh, it is the wrong function. I'm sorry. LN parser procedure declaration. And this one has this result, and it returns a LN3 procedure declaration pointer. So we can return we can add the return type here. The return types aren't checked yet, but we will need them someday when we implement error checking and type checking. So let us look what is LN3 procedure declaration. It has a lot of fields. It has the return type, it has parameters, temporaries, and it has body and length of the body. Maybe we can define the main function already during the parsing. It wouldn't be the best solution, but it would probably be the first step. Or name is not length is not the length of the body, it is the length of the name. But actually this body is a list of statements, I suppose. I definitely already have a type for the statements. So instead of word, we can use the body type here, the LN3 statement type here. And if I look how it is used, so body is assigned here, and it is this parameter head, and parameter head is LN parser statements, and this one probably returns a list of statements. So it returns what? The first statement, so the first statement in the list of statements, and it has this type. And now we copy this body field into the module declaration. Procedure declaration should be defined, of course, before the module declaration, and that means that we can use the procedure declaration pointer as the type of the procedures field, and it doesn't compile. And this actually looks fine as well. So statement, this is for conditional statement, and this is still for if statements. Exactly, this is the body parsing. Then we skip the end keyword and leave this procedure, about the procedure declaration. The procedure declarations parser skips the semicolon. Actually, if we parse the program, the thing that the stage that we are implementing should be able to compile itself and to compile the next stage. That means that we cannot just assume that we have this begin-end block at the end of the module, because only the next stage will have one, but not this one. I have end of file token. That would be interesting actually to see what the token is after we parse all the procedures. So here we parse the module, we parse the procedures, and Alexa read. I'm not sure whether the read function skips the token or not, but I actually can just read the token. So a token is an Alexa token. We have a token here that we use, and if it is not a program that we raise an error, but here we can say that token is an Alexa read from the cursor. Okay, I cancel the compilation. It seems to work more or less. So Alexa token is a record, and the first field is the kind of the token. And let us just print. The compiler outputs the generated assembly just to this the out. So everything that we output goes to the assembly file that is generated, and for debugging we can just print an assembly comment with a new line and the 0 and the string and 0 character is this, and then we pass the token kind to it, and I push the stream. Unfortunately, it takes some time, but we compile, because we work on the 20th stage and not the 21st. We need to compile the 20th stage twice and the 21st. So where can we find the output? I think that output can be found in the boot stage or the 21st stage, and we have 63 where there. So an Alexa kind, this is this list, and I hope that 63 is end of file. To check this, we add another argument and we write an Alexa kind e of. Yes, they have the same value. So the cursor, the tokenizer cursor, is pointing to the end of file, and here we can actually I will just define a second parser function. So we define procs elna parser module body. We need the tokenizer in this function, and this function will return elna3 statement, I think. elna3 statement, exactly. So a list of statements, and we can actually define a variable right away that we call result of the type pointer to the first elna3 statement. We initialize this variable with a nil because it is done automatically, and we return this result. And now, so we move this function in here. We then also need to define a token variable. Actually, I don't know, probably just the previous function should check the condition, not sure. But well, we set in the result body to the elna parser module body. Module body is actually wrong. It is not. It isn't a module body, but it is a program body. Let us rename it, because someday we will have also modules, and modules do not have a body. This is just modules. So I actually can go to another screen and do the compilation here so that I can do it in parallel. And I just call Ninja, and then we can continue work here. Okay, and it seems to fail. Because of course the function needs the cursor. And here we can now say that if the token is of kind Elna token kind begin, I think. Elna lexicon begin. Then we can skip the begin token. Alexa. Oh, peak is the correct function, I think. Yes. Actually, we do not want to read the token. We want to peak, so it doesn't skip this token. I don't know what happens if I skip the end of file token, whether I handle it so that the pointer doesn't point beyond the end of file. But we won't find it out now. Exactly peak, and then we can skip because it is begin now, and now we can skip this token with an Alexa read cursor, and now we can parse the statements. Procedure declaration, and parsing the statements means that we check for the begin or for the return. Oh, Elna parser statements doesn't parse the return statement. Well, our main function won't have a return statement, but I think actually it wouldn't be bad to have a return statement so we can return the exit code from this function. But we begin just with the list of statements without anything else, and that would mean that we just, if we have begin, so we have two possibilities here. We can return an empty list of statements. Empty list of statements will be nil because I cannot return just empty list because the list pointer, the entry pointer of the list is just a part of the statement itself. So actually we shouldn't allocate the result before we use it. I just assign Elna parser statements to the result. Then, and that's it. So we have to skip two tokens after that. We can skip the end token and the period token, but this actually will be enough for testing, because after these two tokens, after the statement list, nothing else can appear in the program. But I can't compile it, and it does look like a syntax error that I do not see. Elena Lexokind is this is the Elena Lexokind, I think. Yeah. Not a syntax error, but a wrong type name. So this looks fine now. And that is actually it. So we can now, I will just save the current status so I can revert if needed. I save the compiler in stage 20, and 21 isn't important for now. And I have a reconvert task that copies the stage 20 in the 21. And then let us go to this function in the top half, I think, program body, and here we will switch to the boot stage 21, and we will rewrite. Oh, it won't work. We should convert with these functions before, but we can at least test. I still have to convert these statements to the intermediate representation, so it is available in the compiled in the produced assembly. But we can at least test it. We remove the procedure declaration and also the comment, I suppose, and it should fail with the start or main function is not defined or something like this. Undefined reference to the main function, because we do not write it into the assembly yet. We do it now. Let us find where. So the next stage will be name analysis and stuff like this. We are not interested in that. I think that the stage that we need now is the TIC stage 3 address code generation, and it will have also something like procedures function, and we want to find where this function is called. So it gets the module declaration, and it calls this TIC procedures function, and the declaration of the body should be just appended to the code section of the 3 address code. How do we achieve that? The procedures function will be actually almost, it won't be almost the same. So it has this first procedure function. How big is actually this TIC procedure declaration? Because it should just call the compiler for the statements in a loop. No, it does more. It converts the parameters and then the statements basically. And it takes the result body, and result body is probably the statement list. LNATIC statements. Oh no, it is the list of result body. Sure, it is the body of the result, so it is the instruction list. What is the parser node? Parser node is a procedure declaration. So we actually need to call this LNATIC statements function, but we also need to generate a new declaration. Let us go here to the back to the stage 20, so we can work with two screens or two views on the source code. And now parser program body. This isn't interesting. So LNATIC module declaration. LNATIC program body. The parser node will be in this case LNAT3 statement. LNAT3 statement. The result will be still a procedure because we need to the procedure name is dependent on the operating system that is used. I wonder whether the procedure name should be defined later, for example, during the assembly generation. It kind of doesn't matter, I think. So let us call... for now, it isn't important. We just want to have this program body in the programming language itself, where it is converted to the main function isn't that meaningful now. So we will do it in the 3 address code. I suppose if it causes some problems later, we can change it and move the generation, for example, to the assembly generation or whatever. Our result, as said, is then a TIC procedure, and we allocate the memory and set the next element to 0. Then we initialize the body and we set the name of this function to main and the length to form. We look up this name in the symbol table and we save this symbol table in the symbol table of the procedure. Theoretically, the main function does not need a symbol table because we do not have local variables. We probably will have parameters later, but I haven't allocated a symbol table for this thing, and I actually not sure where it is allocated. Okay, we skip this to two things. I need to add the symbol table, I think, in the next step. But for now, so we set the type, then we visit the parameters and set the parameter count to something. This function does not have parameters, so we set the parameters itself to nil and result count to 0, and then we visit the statements and return the result. And the statements in this case are the parser node itself. So result body is fine, but this is not okay. It passes the symbol table as argument. It will crash, I'm pretty sure. We pass a nil to it for now, and here we pass the parser node itself. And now we will return a TIC module. And we just need to assign what is actually called. It is an instruction list, so we need to dereference it to access the pointer to the next instruction. I actually had a concatenation function for the instructions, but I think they can append only a single instruction. But we know that that at this point we have at least some functions, so it won't be nil, and we can assign the result, the thing to it. Elna TIC program body, and we pass the parser node body to it. And probably we only want to do it if the parser node body isn't nil. So, what is result code? The result is Elna instruction module, and code is of course just a word, so it is a pointer. It is a pointer to an instruction, I think. No, not to an instruction, to why actually code it just the result next? Elna 3, not Elna 3 module declaration. Elna instruction module. Code and data. and here we assign LNTIC procedures, and LNTIC procedures returns a pointer to the LNTIC procedure. And LNTIC procedure has this next reference. This Helm instruction module is used for two things, I think, for the assembly exactly for the assembly and for the TIC. Yeah, we do not have a cast operator now, so we need to define an intermediate variable, and this intermediate variable will be of the type LNTIC, what was it, procedure, I think, procedure, LNTIC procedure, and instead of assigning it direct to the code, we assign it to this code variable, and then we set the result code to code. And here we can just say that code next this still will probably break without a symbol table with a segmentation fault. If I remove this call, it should fail with a linking error that the main function isn't defined. Okay, let us look where is the symbol table is set. So we have this global symbol table, or symbol table global probably, variable, and somewhere I enter symbols into it. For example, here during the Elna name type declaration. Okay, this is a lookup enter exactly Elna name procedure declaration. We can actually define a symbol table for the main function, but during the name resolution we probably do not know the name of the main. Okay, it is main for now. I just will define it since I know the name. It is the name from the libc, but we can use it, I suppose. What is this? Module declaration exactly. This current path thing isn't needed anymore, actually, I think. So if person node body isn't nil, then then we call Elna name program body, and we pass the parser node body to it. Then we need to define this procedure, and as its argument we get the parser node for the Elna tree statement that we actually do not need. And it will do almost the same what let us move this function a bit. So I actually want to find Elna name procedure declaration, and we define this program body function below it, and we do almost the same. We create a new symbol table and save it into a variable. Then we create a new symbol info for this symbol table, and name procedure temporaries for parameters and temporaries. We do not have this yet, and we just put this symbol table into the global symbol table. So it is symbol table global. Parser node will be main, and the length will be 4. Global symbol table and a name program body. Oh, of course, I do not updated the next stage. For updating it, we just need to remove this this line. So let us do rake convert. Okay, it still crashes, so that doesn't help. If parser node body isn't nil, then all this current part is used to visit all the procedures in the list. So we still need this variable. I skipped. Of course, I skipped the creation, not the creation, but passing the symbol table to the 3 address code. So this is TIC program body, and what we actually need is TIC procedure declaration or something like this, and TIC procedure declaration, and here we look up the symbol table and save it in a variable symbol info. This is just done after the setting the name of the procedure, and the name is main. Parser node length and then we save the symbol table in the result, and we pass it also to the visitor. The 21st stage will still fail. So now we have undefined variables in function main, undefined reference to initialize global state. Oops. So when we compile the 21st stage, we have undefined references to the function called from the main. I actually not sure why. Next, initialize result body. This is what program body? Result body, well, it is main. Symbol table lookup main in the global symbol table. And copy this symbol table into the result. There are no parameters. Parser node and result symbol table, and return the result. In TIC program body, we check whether the body is nil and assign the result to the next element of the code. So we have this name analysis. For the procedure declaration, just have the name, the length, and the body, and actually nothing else. What stage fails actually? So the 21st stage, CLS, the boot. Actually, this is the stage that is generated by the stage 20. Build boot stage 20. Not 20. 21 CLS. Or I think it does. It has the main function of type function. It has the directive global main, so it is exported. And it cannot find, for example, the compile function. Main It isn't here, but compile is defined actually just before. A lot of functions actually, the most functions are missing. Yeah, and I know why. The code is not the last element of the list, it is the first element of the list. So I keep the first element and override the rest of the list with the main function, which is of course not fine. Code is Elna TIC procedure. The one solution would be to also save the last element of the list in this TIC procedure, or we can just find the last element if we iterate the list. Code next. So this is the result code. Oh, this is the run stage. Code next. This is the result code. This is fine. This is the first element of the list, and it remains as is. Then let us rename the variable into the main code. The main code is also not the best name. So before we call this function, we need to find the actual element, the last element of the list. So if, and we can actually assign result code to the code. And if code next is nil, then we can write the main function. We can append the main function to it. We can actually fix the case where we do not have any procedures, but only the main procedure. In this case, the code would be nil, so we can say if code is nil, then just assign this one goes away. Then we just assign this function to the result code, and that's it. This is actually also a bit stupid because we will check this code for nil value on each iteration. Probably we can just define a label here and jump to this label in this case. So I just say no. I still will check it each time. So if code is nil, then the result code is the result of the compiling the main function. If else if code next is nil, then we found the last element and we can assign this thing to it. Otherwise, we need to assign the code variable the next element. In the code list, and we need to jump. This one is done once, and then we need to jump to this loop. So we parse the procedures. We assign the result code to the code variable. If it is nil, then we assign to the result code the body. If it isn't nil, but the next element is nil, then this is the last element. And here we know that the code next is not nil. We assign it to code and jump to the loop again. It is not the best implementation, but it could get us step forward. Yes, that looks better. Now we need to convert. Code is nil. Now we need to go to the stage 21. We need to update it and remove these 3 lines. Okay, now it compiles. And now we have a working implementation. I actually, I do not know how I can do it better, to be honest. Program body. Yeah, I can do it at the beginning. So I can add an end label here, and what I actually can do, I can check whether basically before I go into the loop, I can check if code is nil. Then jump to the end label. Oops. To the end label, not to the loop. Otherwise, you go into the loop. And at this stage, I know that code isn't nil. So I can just check the code next. And we do the last compilation. We implemented this feature, but I think that I won't start the new stage because it is a bit too little for starting a new stage, but when I start a new stage, I can replace the main function with a program block. And that works. And I would say that we are done for today.